Hi, in this video we are going to solve exercise 4, 5, maybe 6. So exercise 4, remark the three parts of this question are independent. So in the complex plane referred to a direct orthonormal system OUV, we have the points M and M prime of affixes Z and Z prime related by this relation. Z prime equal to Z over 1 plus ZZ bar. Suppose that Z equal X plus IY and Z prime equals X prime plus IY prime. Write X prime and Y prime in terms of X and Y. So to write X prime and Y prime in terms of X and Y, we take this relation. We replace Z by X plus IY and Z bar by X minus IY, and we calculate Z prime, then the real part X prime, and the imaginary part is Y prime. So here, part A, Z prime equal to Z over 1 plus Z, Z bar. Z prime equals, we replace Z by X plus IY. It becomes 2X plus 2IY over 1 plus X plus IY into X minus IY. 2X plus 2IY over 1 X plus IY into X minus IY, it will be X squared plus Y squared. So Z prime, here 2X, the real part, X prime is the real part, equals 2X over 1 plus X squared plus Y squared. And the imaginary part, Y prime, will be equals 2Y over 1 plus X squared plus Y squared. Second part, find the set of points when X prime equals 1 over radical 5. X prime equal 1 over radical 5. So X prime that we get it here, we put it equal 1 over radical 5. So X prime is 1 over radical 5 equal to X over 1 plus X squared plus Y squared. Cross multiplication, X squared plus Y squared minus 2 radical 5X plus 1 equal to 0. This is the equation of a circle. To find the coordinates of the center, M belongs to a circle of center. A is minus coefficient of X over 2. Center is IAB. A is equal minus coefficient X over 2, which is minus 2 radical 5 over minus 2, or minus coefficient X is 2 radical 5 over 2, we get radical 5. B is equal minus coefficient Y over 2. Coefficient Y is 0, over 2 is 0. R equals radical A squared plus B squared minus C. A is radical 5 squared بيصير 5. B is 0 minus C, this is C, the constant here, equals 2. So M belongs to a circle of center radical 5, 0, and radius is 2. Now part B. In a direct orthonormal system OUV, let A be a point of affix I, B of a point of fx minus radical 3. And we have z equal minus a over b minus a. Write z in the algebraic form and in its trigonometric form. Z equals minus a over b minus a. Minus a is minus I over minus radical 3 minus I. We replace a by minus I, b by minus radical 3. By using the calculator, z equals 1 over 4 plus radical 3 over 4 I. Now, by using the calculator, we can calculate the modulus is equals half, and the argument is pi over 3. The argument is pi over 3. So z equal half into cosine pi over 3 plus I sine pi over 3. Part 2. Give the geometric interpretation of modulus of z and argument of z. Modulus of z and argument of z. Modulus of z is a distance. I need to find which distance. Modulus of z equal modulus of minus a over modulus of b minus a equal minus modulus of za over zb minus za equals oa over ob. Modulus of z is oa over ab, which is half. And argument of z, argument is an angle. Argument of z equals argument of minus za over zb minus za equal argument, I multiply by minus, numerator and the denominator, it becomes za over za minus zb. So argument of zoa over zba, it is equal angle oa ba. oa ba, or I can put it pi plus ab pi, or we can put it like that, or I can put it AOAB. AOAB. Third part, what's the nature of triangle OAB? What's the nature of triangle OAB? We have determined that modulus of Z, we have determined that modulus of Z equal half, means OA over AB equal half. It means that AB equal to OA, and the angle OABA, OABA, that we can write it as AOAB. If we reverse the two, we get the same angle, AOAB equal pi over 3 in 60. This is 60, and OA equal half AB. So this triangle is semi-equilateral. Triangle OAB is semi-equilateral triangle. Part C. Consider in a direct orthonormal system OUV the complex numbers Z1 equal 1 minus I and Z2 equals minus radical 3 plus I. Calculate the moduli and the arguments of Z1 and Z2. هذا simple by using the calculator. So part C, Z1 equal 1 minus I, then modulus of Z1 equals radical 1 squared plus 1 squared equal radical 2, or by using the calculator, argument of Z1 equal minus pi over 4, modulus of Z2 equal radical 3 plus 1, radical 4, which is 2, argument of Z2 equal minus equal 5 pi over 6. 5 pi over 6. Part 2. Let Z equal Z1 bar times Z2 power n, where n is a natural number. Write Z in the trigonometric form. Write Z in the trigonometric form. It is easier since we have power. So Z1 bar, Z1, I can write it in the exponential form, is radical 2 e minus I pi over 4. So Z1 bar is radical 2, and Z1 bar is radical 2 ei pi over 4. Z2 is 2 ei 5 pi over 6 to the power n. It will be radical 2 ei pi over 4, 2 to the n, 2 to the power n, e I 5 pi over 5 pi n over 6 equals radical 2 times 2 to the n, this is the modulus, cosine pi over 4 plus 5 pi over n over 6 plus I sine pi over 4. In this one, I can write it 2 radical 2 to the n radical 2 e I pi over 4 plus 5 pi over 6n. We add the powers. I change it to trigonometric form. In each of the following, find a natural number k, z1 to the power k is real. For the complex number to be real, its argument is k pi. We say argument of z1 power k equals m pi. So I put argument of z1 to the power k equal m pi because it is real. I put m pi because here we have k. So k argument of z1 equal m pi. The argument of z1 is minus pi over 4 equal m pi. I remove n with n, so k equal minus 4n. So k is a multiple of 4, we can say. Part B, z1 power k is pure imaginary. For the number to be pure imaginary, its argument is pi over 2 plus m pi. So k argument of z1, since it is pure imaginary, equal pi over 2 plus m pi. K into minus pi over 4 equal pi over 2 plus m pi, 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 pi. So k equals minus 2 minus 2n. The last part, Deduce the nature of Z1 power 14. Z1 power 14, argument of Z1 power 14 equal 14 argument of Z1 equal 14 into minus pi over 4 equals minus 7 pi over 2. We simplify. We can put it as minus 4 pi plus pi over 2. So it is pure imaginary. Since its argument is pi over 2, then it is pure imaginary. This is all about exercise 4. Now we start with another exercise. Exercise 5. In the complex plane referred to an orthonormal system OUV, we have 2 points M and M prime related by this relation. Z prime equal 1 plus I Z bar. In this part only, we take Z equal EI pi over 3. Write Z prime in the exponential form. Now, Z bar, Z EI pi over 3, Z bar E minus I pi over 3. So if I write this one in the exponential form, 1 plus I multiply it by E minus I pi over 3, we get Z in, or Z prime in the exponential form. So Z equal EI pi over 3, Z prime equal 1 plus I, since we have Z bar, it will becomes E minus I pi over 3, since argument of Z bar equal minus argument of Z. 1 plus I can write it in the exponential form. The modulus of 1 plus I is radical 2, والargument of 1 plus I is pi over 4, is EI pi over 4. It will become radical 2, we add, we get 3 pi, we get minus pi over 12. This is the exponential form of Z prime. Verify that part B, Z prime power 6 is pure imaginary. So for a complex number to be pure imaginary, its argument should be pi over 2 plus k pi. So I put argument of Z prime power 6. Argument of Z prime power 6 equals 6 argument of Z prime equals 6 into minus pi over 12 here. We get minus pi over 2. So Z prime power 6 is pure imaginary since the argument is minus pi over 2. Now 2a, show that modulus of Z prime equal radical 2 modulus of Z. So I can use this relation. I use the modulus of Z prime. So Z prime equal 1 plus I times Z bar, modulus of Z prime equal modulus of 1 plus I times modulus of Z bar. Modulus of Z prime, modulus of 1 plus I is radical 2, and we know modulus of Z bar equal modulus of Z. It is a property. Deduce that if M moves on a circle, if M moves on a circle with the center O and radius radical 2. M belongs to a circle of center O and radius radical 2 means OM equals radical 2. Deduce, and we are going to use the previous result, this previous result, that M prime moves on a circle whose center and radius are to be determined. M prime moves on a circle whose center and radius are to be determined. Deduce, so I have to use this property. Modulus of Z prime is OM prime equal radical 2. Modulus of Z is OM. I put instead of OM radical 2. So OM prime equal radical 2 times radical 2, which is 2, means M prime belongs to a circle of center O and radius 2. So since modulus of Z prime equal radical 2 times modulus of Z, modulus of Z prime is OM prime, modulus of Z is OM. OM prime equal radical 2 times radical 2 in OM radical 2, since M belongs to a circle of center O and radius radical 2. So OM prime equals 2, means M prime belongs to a circle of center O and radius equals 2. Part 3. Let Z equal x plus iy and Z prime equal x prime plus iy prime. Express x prime and y prime in terms of x and y. So we go to the given relation and we put instead of zx plus iy, then the real part x prime and the imaginary part will be y prime. So z prime equal 1 plus I times z bar will be x minus iy. We expand, 1 times x is x, minus iy plus ix, minus I squared y plus y. So real part is x prime, which is x plus iy. The imaginary part is x minus y. So this one is x plus y plus I into x minus y. The real part is x prime, so x plus y is x prime, and the imaginary part is y prime. For all z different from 0, n is a point of affix z bar, يعني n عندها coordinates x minus y. Prove that triangle O and M prime is right isosceles with principal vertex n. For triangle to be right isosceles, we have to prove it right. We can use Pythagoras, we can use scalar product, we can use a slope. To prove it is isosceles, we have to calculate NO NM prime. NO should be equal to NM prime. So here, vector ON هو x minus y. Since n is the affix of z bar, الآن عندها coordinates x minus y. So ON, the distance ON equal radical x squared plus y squared. Vector m prime n is equal to xn minus xm prime. Xn is x minus x prime, which is x plus y. We get minus y. Yn, which is minus y, this is minus y here, minus ym prime, which is x minus y, we get minus x. M prime n equal radical x squared plus y squared. So here On equal m prime n so the triangle is isosceles with vertex n. To prove it is right, we can calculate the length of OM prime, we apply Pythagoras, or we can use scalar product On dot Mn dot M prime n, هي xx prime plus yy prime. xx prime, يعني x times minus y plus minus y times minus x, it will becomes minus xy plus xy will be 0, means the vectors On and M prime n are perpendicular, and we have two equal sides, then triangle O and M prime is right isosceles. The last exercise, 6. We have 2 points A and B in a complex plane. A and B are 2 points in the complex plane with affixes 1 and minus 2. ZA, ZA equal 1, ZB equal minus 2. And ZB equals minus 2. M and M prime are 2 points with respective affixes Z and Z prime related by this relation. Z different from 0 because Z in the denominator, it should be different from 0. Write Z in the exponential form in case Z prime equal 1 plus I. I replace Z prime by 1 plus I here. I calculate Z bar. I calculate Z, then I calculate Z in the exponential form. So Z prime is 1 plus I equals Z bar plus 2 over Z bar. Cross multiplying, we will get Z bar plus IZ bar, Z bar plus IZ bar equals Z bar plus 2. Cross multiplication. Z bar to one side, Z bar and Z bar 0. So IZ bar equals 2, Z bar equals 2 over I equal minus 2I. We need to write it in the exponential form. The exponential form, it will be equal to E minus I pi over 2. This is Z bar. Yani Z equals 2E I pi over 2. Part 2. show that the length OM prime equal BM over OM. Distance. Distance, and we are going to use modulus. We are going to use modulus here. So Z prime, modulus of Z prime equal modulus of Z bar plus 2 over modulus of Z bar. This one, I have to put it all of it bar. Since 2 is real, it's here Z plus 2, all of it bar over modulus of Z bar. Property, the modulus of bar equal modulus of Z plus 2 over modulus of Z. So modulus of Z prime is ZOM prime, Zm minus Zb, Zm minus Zb, 2 is the fx of b, over Zm or Zom, means Om prime equals Bm over Om. Part B. Part B, we have to use part A, okay? If modulus of Z prime equal 1, then M moves on a line to be determined. How to prove that M belongs to a line to be determined? Modulus of Z prime is 1, means OM prime is 1, means BM over OM equal 1, means BM equal OM, means M is equidistant from O and B, means M belongs to the perpendicular bisector of OB. So modulus of Z prime equal 1 means OM prime is 1 equal BM over OM, means OM equal BM, then M belongs to the perpendicular bisector of OB. Part 3. For every Z different from 0, show that Z bar into Z prime minus 1 equals 2. So it is simple. We replace Z prime by its value here. Then we take the LCM here and we will get 2. Z bar into Z prime minus 1. I replace Z prime by the value. So Z bar into Z bar plus 2 over Z bar minus 1. We take the LCM. So Z bar plus 2 minus Z bar over Z bar. Z bar simplified. Z bar minus Z bar 0, we will get 2. Part B. For all Z different from 0, verify that argument of Z prime minus 1 equal argument of Z plus 2k pi. So we use this relation. And we put argument on each side. So argument of Z bar into Z prime minus 1 equal argument of 2. The relation that I proved in part A, I put argument. Argument of the product equal argument of Z bar plus argument of Z prime minus 1. Argument of 2 is 0. 2 is real and positive. Its argument is 0. Argument of Z bar as a rule is minus argument of Z plus argument of Z prime minus 1 equal 2k pi. So argument of Z prime minus 1 equal argument of Z plus 2k pi. it is done. The last part, suppose in this part z prime equal 1 plus ei theta. Verify this vector relation. Verify that OM equals 2am prime. OM vector equal to am prime vector. I have the relation z prime minus 1 equal to over z bar. Z prime minus 1 equal to over z bar. We have z bar equals z bar into z prime minus 1 equal 2. So z prime minus 1 equal 2 over z bar. Z prime is 1 plus ei theta minus 1 equal 2 over z bar. 1 minus 1, 0. So z bar equals 2 over ei theta. So z bar equal 2e minus I theta. I put it in the numerator. So z equals 2ei theta. This is z. Now z equals 2 into z prime ei theta. Z equal to ei theta. So it is equal to into z prime minus 1 because we're in a z prime equal 1 plus ei theta. So ei theta is z prime minus 1. This is I theta, ei theta. I can put it 2 into z prime minus 1. So zm equals 2 into zm prime minus za. So zom equal 2zam prime and om equals 2am prime. This is all about this revision, about this worksheet. Study well for the final.